big sac. It has adipose tissue attached to it, which is normal. And the thing about the pericardial sac is it does not stretch. So if there is any kind of fluid buildup in the pericardial sac, as it builds up, and there won't be a hole in it like this is, then it will prevent the heart from filling during diastole, because the heart fills by gravity feed only, okay? And so you'll die. Huh?
That's why you would have to remove.
You'd have to remove the fluid or die. Yeah, there was a lady that we knew at our church, and she had extremely slow heart rate, and, I mean, dangerously slow, like less than 40, which is, basically bradycardia. It's real serious. They took her in, took 1.5 liters of fluid.
Oh my gosh. What did that increase her heart rate up to?
Huh?
She didn't have any other symptoms?
She was, faint-headed. I mean, she was, she had like a fever. But, that was real serious, so they've been watching her ever since. The point is that may or may not increase the heart rate.
Oh,
Clearly,
okay.
it will allow for increased filling.
Right.
Because what happens is it's like a boa constrictor around you. You get more fluid, and then during diastole, it can't fill up as much because there's no space.
Okay.
So this is a potential space. It just provides lubricating fluid so that there's no friction, friction on the surface. And it's kind of cool because you can see, that's the only reason I got this out. We'll talk about the vessels momentarily. Now, what I want to do now is focus on the heart that doesn't have the pericardium. This here, and this over here. So there is a little bit of pericardial sac here, which is all that's left, which, it just isn't the same. But it does allow you to differentiate a couple different things. So if I hold the heart in this orientation, one of the things that's apparent is you see there's this large groove, and there's a blood vessel that goes down, and it's going, 30 to 45 degree angle, okay? That's a landmark that you're going to want to remember, because it tells you that you're looking at the ventral side of the heart, or the anterior side of the heart. On the back side, it's almost vertical. Here's the groove, and here's the vessel going right down there, so it's going this way. So if it's going like this, you're looking at the anterior side of the heart. If it's going like this, you're looking at the posterior side of the heart. Okay? And that's important because it tells, once you know what side of the heart you're looking at, then you can easily diagnose what ventricles are, which ventricles are which, where the atria are, and so on and so forth. So basically, from the anterior side, if you see the base, the base of the heart's here, and that's where the pericardial sac emanates from the base and goes around embryologically, and the apex of the heart is down here, the pointy part. Okay, so here's this line here, and the groove is called the anterior interventricular sulcus. Okay, and the artery and vein in there are the anterior interventricular artery and vein. So they tell you two things. Not only do they tell you where the left and right ventricles are, but they kind of mirror, in a general sense, below that where the interventricular septum is deep in the heart. Okay? So if you're looking at the ventral side of the heart or anterior side, the apex portion right here is all left ventricle. Okay? When you look at the upper side of this is the right ventricle. So that tells you that this little flap right over here, this flap is one of the auricles, as the Greek used to call them. Now we just call them atria. The auricle used to be the ear-like flap of the atrium. The atrium is a place where the blood comes back to the heart, just like the entryway, like an atrium to a house. And so this would be the right atrium or right auricle, and then the other one over on the left side would be the left atrium or left auricle. Okay? So you see these elephant ear-like flaps. Okay? So essentially, if it's on this side, it's the right atrium. Over on the other side, it's the left atrium. Okay? And then you also see another large vessel that goes in between these two. What do you think that one is?
Coronary? Oh,
Right here.
aorta?
Okay, so look and see where it's coming from.
The pulmonary.
It's a pulmonary
Oh.
trunk. Why? What ventricle is it coming out of?
The right
Right
atrium?
ventricle, right? There it is. Here's my finger, right there. Okay. So this is the pulmonary trunk. So from when you're looking at the ventral side of the heart, the first vessel that you see is going to be the pulmonary trunk. Behind that, if it's present, is going to be, oops, here's the aorta here, it's cut. Okay? So we don't see that. Everybody thinks, well, because it's rounded and stuff like that.
So
And
the
this-
aorta is behind
the aorta is behind it on the ventral side. Now, this one, we can't, a lot of the stuff is covered up, but this is, here's the aortic arch right here going over. It's actually still intact. And you see two other vessels, one here, one right there. Those are the first two vessels that come off of the aorta. The first one that comes off is the left brachiocephalic, and the second one that comes off is the left subclavian. And there's variation to that. It will, you know, sometimes they come off in sequence like this. Sometimes there's a common brachiocephalic, and then a left subclavian comes off of that. There's a fair amount of variability in terms of where they branch off. Okay. Sorry. Okay. So as we're looking at this, we'll go back to our left heart here. The thing to keep in mind is that there are also, we've looked at the two outputs, the aorta and the pulmonary trunk, and then we have to look at the inputs. So if we look at the right side here, which is here's the right ventricle, here's the right atrium. The right atrium has an opening, one that goes in here, and so I got my finger in here, and so I'm kind of wiggling the little ear-like structure. So I'm in the right atrium, okay? So that's coming in from the top of the body, from the head and shoulders. That would be the superior vena cava. The other one comes up from the bottom of the body, and actually it's a fairly thin vessel, and you can see it right here. Here it is right there. See that little opening? I can put my finger all the way through, or I can go all the way through from the other side. So the point is, this very thin vessel is the inferior vena cava. Now, you know, why the other one's bigger is, I don't know, just do this. I don't know why it is in this particular one. But they both end up in the same chamber. They both fill the vessel, the atrium, by gravity feed. There's no pressure. Okay, so this is just gravity feed situation. Okay, and they both end up, the inferior vena cava brings back blood from all of the lower parts of the body below the heart. The superior vena cava brings all the blood down from the anything above the heart. Okay, and they both end up in the right atrium right here, and from there, and you can't see this, I'm pushing my finger down now through the tricuspid valve into the right ventricle. Okay, we'll look at that in a minute. Now, on the other side, after the blood leaves the pulmonary trunk right here and goes to the lungs, it comes back to the heart through the pulmonary arteries. Okay? And in most cases, and this is no exception, there's four vessels and they're cut. And if you cut it very close to the atrium, you don't see the vessels, you just get this big hole. So that big hole there is where there were actually four vessels coming in. There's two from each lung, two pulmonary veins. So the other piece to remember has to do with the naming of blood vessels. Any blood vessel that carries blood away from the heart is an artery. Any blood vessel that carries blood to the heart is a vein. It has nothing to do with whether it has oxygen or not, because the pulmonary trunk, actually, which carries blood from the right ventricle to the lungs, is deoxygenated blood. The pulmonary veins, which are bringing things, you know, oxygenated blood back to the heart, that's oxygenated blood. So think about you know, whether the blood's going to the heart or away from the heart in terms of arteries and veins. Okay, and forget about the colors. Doesn't matter. Okay, in the old days we colored red and blue. It doesn't count here. Okay, because we're looking at two different circuits. Okay. Let's see what else. Where am I here? Ventricle, veins, ligamentum arteriosum. So there is a junction between the pulmonary trunk, and the aorta. So I'll just get these guys together, separate them out. You can see there's a lot of connective tissue right here, and there's normally a gap in between those two. You can't really feel it here. During the fetal development, there's essentially an opening, and that closes after birth, and it actually, on both sides, there's a spasm so that the opening